The useState hook allows you to add state to a functional component. It takes an initial value as an argument and returns an array with two elements, the current state value and a function to update it. In this example, we start with a count of 0 and update it every time the increment and decrement button is clicked. The useEffect hook allows you to perform side effects in a functional component. Side effects include things like fetching data from an API, updating the DOM, or subscribing to an event. In this example, we fetch data from an API and update the component's state with it using the setData function. The useContext hook allows you to access a context object in a functional component. Context is a way to pass data down the component tree without having to pass props manually. In this example, we create a theme context with the default value of light and use the useContext hook to access it in the theme button component. The useReducer hook allows you to manage complex state in a functional component. It's similar to the useState hook, but instead of a simple value, it takes a reducer function and an initial state. In this example, we define a cart reducer function that takes a state and an action and returns a new state object based on the action type. We then use the useReducer hook to manage the cart state with the cart reducer function. We also define two functions, add item and remove item, that dispatch actions to the cart reducer or to add or remove items from the cart state. Finally, we render the shopping cart with the cart items and buttons to add or remove items. When the buttons are clicked, the add item or remove item functions are called to update the cart state using the dispatch functions written by the useReducer hook. The useCallback hook allows you to memoize a function so that it's only recreated when its dependencies change. This can help improve performance by preventing unnecessary re-renders. In this example, we define a search bar component that takes an onSearch prop function. We use the useCallback hook to memoize the handle query change function so that it's only recreated when the onSearch function changes. The useMemo hook allows you to memoize a value so that it's only recomputed when its dependencies change. This can help improve performance by preventing unnecessary recomputations. In this example, we define an expansive calculation component that takes two props, A and B. We use the useMemo hook to memoize the result of the calculation so that it's only recomputed when A or B changes. The useRef hook allows you to create a mutable ref object that persists for the lifetime of the component. You can use it to store and access values that don't trigger a re-render. In this example, we define an input with focus component that creates a ref object with the useRef hook and attaches it to the input element. We use the ref object to focus the input when the focus input button is clicked. The useLayoutEffect hook is similar to useEffect, but it's executed synchronously after all DOM mutations. This makes it useful for manipulating the DOM immediately after a component is rendered. In this example, we define a resizable box component that uses the useLayoutEffect hook to measure the size of the div element. We then use the size values to render the width and height of the box. This hook also adds and removes a resize event listener to update the size values when the window is resized. UseDebugValue is a hook that allows you to display custom debugging information for custom hooks in the React DevTools. This can be useful for debugging hooks and understanding what's happening behind the scenes. In this example, we define a custom hook called useFetch that fetches data from a URL and returns it. We use the useDebugValue hook to display a custom debugging message in the React DevTools. If the data is loaded, we display a message that includes the number of items in the data. If the data is still loading, we display a message that says loading. When you use the useFetch hook in a component, the custom debugging message will be displayed in the React DevTools. This can help you understand what's happening behind the scenes and debug any issues that might arise. Note that the useDebugValue hook should only be used for debugging purposes and should not affect the behavior of your custom hook. It's a great tool to have in a debugging toolbox when working with custom hooks. The useImperative hook allows you to customize the instance value that is exposed to parent components when using ref. This can be useful when you need to provide a certain interface to parent components, but you don't want to expose all of the internal implementation details of a child component. In this example, we define a custom input component that uses useImperative to expose a focus method and a value property to parent components when using ref. The useImperative hook takes two arguments, the ref object and a callback function that returns an object with the properties and methods that should be exposed to parent components. In the app component, we use the input component and pass a ref object to it. We also define a handle click function that calls the focus method of the input ref object when the button is clicked. When you run this code, you will see an input field with a placeholder text and a button that says focus input. When you click the button, the focus method of the input ref object is called and the input field is focused.